Hello everyone. Today we'll continue with the lecture series of set theory. Today's lecture is about elements of set and different representation of sets. So let's get started. Let us first take a set, let's say A equal to 1, 2, 3, 4 and 5. Now you can easily see that 1, 2, 3, 4, 5 are written in this curly bracket, so they are elements of set. If you want to write that 2 is a member of this collection, that is 2 is the element of this set, we write 2 belongs to A. Likewise, 4 also is member of this set, therefore 4 is belongs to A set. Now we can see easily that 6 is not a member of this set. So to write that the 6 is not a member, we write 6 doesn't belongs to set A. Okay. Now take another example. We are erasing this. Let A equal to A, B, C, D, E and F. Also B is another set where C, D, E, F, G. Now if we ask you A, then put a dash and A, and you have to fill this dash with either belongs to or not belongs to. Well, what we will put here, we will search if A is in this set. We can find that here A is a member of A, capital A set. Therefore, we put belongs to sign here. Again, if we ask you whether A belongs to or doesn't belongs to B, you search the whole set B and you cannot find A, so you will write A not belongs to B. Now the further discussion will be a little bit tricky, so pay attention. Let A equal to 1, 2, 3 and the set B equal to A, B, C, D. Sorry, we don't put B here. Let's say C, D, E. Here you see A is the set containing 1, 2 and 3. B is another set containing sets A, C, D, E. Therefore, B is a set of set. This is a unique type of set. But this is not the trick here. Now, if we ask, does A belongs to A? A dash B. Does A belongs to B? We search the whole set B and we can easily find that A is an element of set B. Therefore, we write A is belongs to B. Now the trick is, does 1 belongs to B? You can say that 1 belongs to A and A belongs to B, therefore 1 belongs to B. But this will be wrong, because if 1 has to be a member of A, I mean, sorry, 1 has to be a member of B, then 1 should present in the set here, not in the element of an element of the set. 1 is not here. We cannot find 1 here. Therefore, 1 is not a member of B. Now, that was the trick. Therefore, you can easily understand what is the element of the set. If you can find a particular element in that set, then we write that element contains in the set. If we cannot find as element in the set, then we write that element doesn't belong to that set. That was the concept on elements. Now we'll move further to the various form of representing a set. There are two popular forms to represent a set. One is set builder form, and another is roster form. When we do not write the elements of the set, just tell some attributes of the set, some special characteristics, then the representation of set is called set builder form. When we write the elements of the set to represent a set, this representation is called the roster form. Till now, what sets we have written in roster form. Let us take an example of the same set. Let us write set A containing the vowels A, E, I, O, and U. We can write this set in another form. Let X such that X is a vowel. Here, two sets are the same. Here we write the elements of the set. One can easily find all the elements here. This set is written in the roster form. In the another form, we write a dummy variable which will represent the elements and say some characteristics about that element. This is called the set builder form of set representation. We'll move further to take some examples to understand this representation better. Here you see, you are asked to write these sets in the roster form. These sets are written in the set builder form. Therefore, the characteristics of the elements given in here in this set, we have to write the sets in the roster form. Let us take the first one. Here they are saying that x is an integer and -3 less than equal to x less than 7. So, and the name of the set is A. Therefore, the elements of A, what will be the elements? X are the integer, and integer can be negative also. Therefore, -3 will be an element. Then -2, -1, 0, 1, 2, 3, 4, 5, and 6. 7 will not be a member because here it is written that x is lesser than 7, and that will be the roster form of the given set which is given in the set builder form. Now move to the next set, set B. We say that x is a natural number less than 6. You all know that natural number starts from 1 and we have to go till the natural number lesser than 6, that means we have to go to the 5. 1, 2, 3, 4, 5. This will be the roster form of the set in this question here. We will now write the set roster form of the third. Here they say x is a two-digit natural number such that sum of the digits is 8. X should be a two-digit natural number and sum of the digits should be 8. Let us write two-digit natural number 1 at the tens place, then we have to make the sum to 8, then we have to put 7 in the ones place. If we put 2 in the tens place, then we have to put 6 in the ones place. If we put 3 here, then we have to put 5 and so on. 4, 4, 5, 3, 6, 2 and 7, 1. That will be the set. These are the two-digit natural numbers whose sum of the digits is 8. Next, we move further and take the next example D here. Here x is a prime number which is divisor of 60. Now you all know that 60 is divided by 3 prime numbers 2, 3 and 5. Therefore, the roster form of D will be this. Then we go to the question number 5 here. E is the set of all letters of the word trigonometry. Now you will understand a different concept here which is told in the definition. Let us write set E here. Now take one by one letter. First letter is T. We write it. Then we got R, I, G, then O, then N, then we get again O, but the elements of the sets will be distinct. Therefore, we do not write it again. Then we got M again, E we have not written the it. Then T is written here, R is written here, only Y is left. Therefore, this will be the roster form of the set in the question number 5. We leave the F as your homework. Please solve it and comment it below. We will move further to the set builder form. Here the questions asking us to write the set in the set builder form. The first set we can see that here is 3, 6, 9 and 12. You can easily find that these four numbers are the first four multiples of 3. Therefore, if we write it in the set builder form, then this set will be x. X is first, x is we can write x is a multiple of 3, and we will restrict this so that x cannot exceed 12. We write x lesser than equal to 12. Now if we see that set, these characteristics here, x is a multiple of 3 and x is lesser than equal to 12, which give us this set. Therefore, this is the set builder form of the roster form here. Now we move further. You can easily find that the second set here 2, 4, 8, 16, 32. Therefore, the numbers here are obtained by multiplying 2 with the previous one. Rather than we can say that there are the powers of 2. Therefore, we can write it here y such that y equal to 2 to the power n. Now n runs from n equal to 1, 2, 3, 4 and 5. You can say, or you can say that n is a natural number less than 6. That will also work. Now if you move further, you can see that this is the powers of 5. You can easily solve this by help of 2. Now move further and see here. Here this set is an infinite set which contains infinite number of elements, but recognize the pattern here. Here 2, 4, 6, all even numbers are given. Therefore, we can write it here y such that y is a positive even number. That's it. Also, in the set 5, here the squares are given. Here we can see that 1 is square of 1, 2 is square of 2, 3, 9 is square of 4 is square of 2, 9 is square of 3 and 100 is square of 10. Therefore, we can write x such that x equal to n square, where n is a natural number less than 11. If you take 11, it will give you 121, which is not a member of this set. Therefore, we take natural number less than 11. That will give us natural number 10. Therefore, when n will be 10, we will get the last member of the set 100. And that's all for the class. Please ask any question you have, and please like and share the video. Bye bye.